Hello, welcome to another math video. Today we're going to start taking a look at trigonometry, and today we're going to introduce the laws of sines, or the laws of cosine, otherwise known as cosine law. So the full derivation you can look at your textbook on page 116. Okay, we're not going to derive the cosine law, and we're just going to use it. There are two versions of the cosine law in front of you. C squared equal to a squared plus b squared minus 2ab cos capital C. Or if you rearrange it, okay, you get that cosine C is equal to a squared plus b squared minus c squared over 2ab. Okay, these are two different versions of the cosine law. Okay, cosine law applies to all triangles and not just right angle triangles. In Math 10, we only worked with cosine, sine, and tangent with right angle triangles, and they only work with right angle triangles, but the cosine law works for all triangles. Okay, work for all. But just like right angle triangles, okay, the labeling convention in its formulas, the small letters, okay, the sides are the small letters. Okay, small letters like little a, little b, little c. And the corresponding angles, or I should say the opposite angle, are capital letters. Capital letters. Okay, why do we want two different versions of the cosine law? Well, that is because we want to use the cosine law to find the angle or the side. If we're looking for the angle, we will use this one because the angle is by itself. So this is used to find angle, and this is used to find side. Okay, because side is by itself and angle is by itself. Alright? Now, I can explain the cosine law all we want, but it's best to see it in action. So here are two questions which we can use the cosine law. Okay? Notice what information are given to us in order to use the cosine law. We cannot always use cosine law, just like in Math 10, we cannot always use sine. We cannot always use cosine, use tangent. It depends on what information is given to us. Okay, remember, little c and capital C are a pair of angle and opposite sides. Usually we know one of them, but not the other. Okay, but we must know the other two sides. Okay, we must know the other two sides in order to find the third missing side, or we need to know all three sides. So in order to use cosine law, we must be either given side, angle, side, and we're missing the opposite side of the angle in the middle, or given three sides and we don't know any of the angles. What do I mean? So for instance, look at this triangle here. What information are we given? Well, we're given a side here, an angle in between, and another side. Angle is between two. One angle is given between two given sides. So this is SAS. Therefore, we can use cosine law. Okay, cosine law. Now, we're asked look for the missing side. We know the two sides here. Okay, the only missing side is right here. So let's label with a question mark. Before we begin though, we would like to label the sides. For this one is somewhat convenient because it's already it's not labeled already, so we have our own choice of what we want to label. We'll do an example. Okay, we'll do a second example where what happened if it's labeled for you already. So once again, we're looking for a missing side, so we're gonna end up using this formula minus, remember, it's not Pythagorean theorem, it's not c squared equal to a squared plus b squared. There's an extra term attached behind it, 2ab cosine of c. Now, writing down the formula doesn't really solve the problem, because what is little c? What's little a? What's little b? Okay, well, take a look at the diagram here of the triangle. Okay, pause this video, think about what would be a good choice for little c, little a, little b, and capital C. Okay, think about it. Remember, these are given. This is unknown. Okay, pause the video and give it a thought. Alright, hopefully you paused the video and did actually try it. And let's see if you agree with me. Now, since we're looking for the missing side right here, so that should be our little c. And of course, naturally, the opposite angle should be capital C. Okay, should be given to us. In this case, it is. Alright, and of course, it doesn't really matter. Either two sides can be A or B, so I'm going to call this one A, this one B. Consequently, the opposite angle of little a is big A, little b is big B. So I label the triangles now. Okay, label the triangles. Now we can plug it in. C squared equal to A squared is 4.75 squared plus B is 7.77 squared minus 2 times A. Notice I put brackets beside every substitution. That is very important. Times cosine of 105 degrees. Don't forget to be in degree mode. Okay, don't forget you're in degree mode. Now, once you plug it in, of course, C is equal to, you have to take a square root of both sides to get rid of the C squared. So I have square root. I punch that into my calculator. Okay, and I got a number. I'm just going to quickly look up my notes here. You should get a number of about 102.0401, etc. Where you take the square root, of course. Oh, I draw the square root way too long. What's going on? It erased all my writings. There we go. Sorry, just quickly write it down again. A squared minus 2 times 4.75 square root, which is about, C is approximately 10.1 3 sig digs, and we find our answer, which is approximately 10.1. Okay, which is approximately 10.1. Now let's look at our second triangle here. 50 degrees is given and two sides. Once again, we want to make sure we're indeed given either SAS or SSS. In this case, we're given side. You do not have to label this, but for demo, I am going to label it out just to show you. Side angle side again with the angle in between. Okay, just if you like to make things easy, always the unknown. If you get to label, always the unknown is C. But what happens if this triangle is already labeled? Let's say I don't know, P, Q, R. Of course, we're looking for little p, right? Of course, this 7 is little q, and 3 is little r. What if it's already labeled for us? How can we solve this problem if it's already labeled for us? Well, that's very simple. We just adapt our formula. First, I'm going to write down the original formula. We're looking for a missing side, so we're using the side version of the formula. A squared plus b squared minus 2ab times cosine of the angle capital C. However, there are no ABCs here. Okay, there are no BCs here. It's only P, Q, and R. Let's play matching. Once again, feel free to pause the video to get you thinking about it. What would you pick as A? What would you pick as B? What would you pick as C? Both capital and small letters, of course. Now, if you pause the video and think about it, or you're just waiting, here is what we can do. Okay, we're looking for little p. So naturally, our C should be P, because that's what we're looking for. Of course, then capital C must become capital P, and A, B doesn't really matter. So A can be R, B can be Q. No problem. You can do what you can. If for the two other sides, it can be either choice. Okay, the key is the angle opposite the side you're looking for. Those are the important one. Okay, those are the important one. So if we rewrite our formula, this becomes P squared, which we're looking for, remember, is equal to R squared plus Q squared minus 2 R times Q cosine of angle P. Cosine of angle P. Now, this information we can get from the diagram. So I'll leave it to you to figure it out on your own. Like leave it out, figure out on your own. But in this picture, in this diagram, okay, you should find that P is approximately 5.57. We have a unit here, centimeters. Okay, I'll leave a detailed work to your own because that's just substitution. Okay, and that's how we can use the cosine law to find a missing side. The key step is actually make sure your label is accurate, okay, and you indeed can use cosine law, which is given SAS. In our next video, we'll look at another application of cosine law. We looked at SAS. How can we use SSS triangles, or I should say, how can we use cosine law to solve SSS triangles? So, with that, have a good day. Please tune in next time for more cosine law.